Hello. Yeah, so this question is going to be sum, part of discussion number 11. And so, um, nothing new as to like what the function does. Uh, what matters is like returning it as like a tail recursive function, writing it as a tail recursive function. And so this function sum is going to take in a number like 1, 2, 3, like list 1, 2, 3, and it's going to output like the sum of all the elements. In this case, it would be 6. And yeah, and so take a little bit of time, think about how you want to solve this problem. And so remember that in the case of a tail recursive function, pretty much like the bread and butter of like what you want to do is that we're going to define a helper function inside, define helper. And so this helper function is going to be basically the sum function, but with an added parameter. And so if you remember like what we did before with maybe sum, we would like maybe call sum on the cooter of the list, and then that cooter of the list would call sum again, and it would go all the way down to the base case where we'd have 0. And what would happen is that we would backtrack up. And so if you imagine I had like the list 1, 2, 3, 1, 2, 3 originally recursive call up here, then we go all the way down 2, 3, and 3, and we're at nil. You can imagine that the base case returned where the list was nil, we would return 0 because there's nothing, and we would kind of like backtrack up. Then from that 0 we would add 3, then we would add the next current element, which is 2, which would become 3 plus 2 is 5, and then we would add that 1 to get 6 in total. And so remember that with tail recursion, we want to get rid of this like path vibe, that backtracking path. We don't want to go back up because since we want to conserve like a constant number of active frames, so we don't want to remember, we have to go back to this function up here and add that 3, add that 2. We want to be able to just say, oh, let's go down, and once we get to the bottom, we should have our result 6 with there without having to backtrack up. And so to do that, remember that for tail recursion, we defined a helper function, and we added an extra parameter, and this parameter is going to accumulate all of the values that we've seen so far, like accumulate our result. And once we reach the base case, we hit the bottom, we should have like a 6. And we're going to return that once the list is nil. And so what's going to happen is that we're going to pass in 1, because that's the first element, to the next call. And this is like the accumulated variable. So we're going to be adding up the elements, and then that's going to be that parameter. And we're going to add the next element, plus 2, and it's going to become a 3. And then we're going to add 3 right here. It's going to become a 6. And once we hit the bottom, we see that it's the base case where it's an empty list, and we're going to return that 6. And so yeah, that's kind of going to be how we're going to solve this problem. And take a little bit of time to like code it up. I just realized I didn't really outline the steps already. But remember, we want to define a helper function, which takes in the same parameters as sum, but you can add accumulator variable. And I usually like to call it so far. Extra parameter right there. And then afterwards, we're going to return a call to helper within the sum function. And that helper call should be like the sum of that list, except done in a tail recursive way. And so yeah, let's take a little bit of time, code that up, and we'll go over it together. And so yeah, let's get started. And so first of all, we want to define a helper function. And I usually call my functions helper. You can call whatever you want. But this is like the general structure for any tail recursive function. The function that you want to turn tail recursive. And so we're going to define helper, and we're going to take in 2 parameters. So one is the original parameter list, and another is the variable so far. And remember that so far is going to be this variable that keeps tracks of like the running sum so far. So in the case of like the list 1, 2, 3, it would be 0, then 1, then 3, then 6. And so yeah, so inside this function, we're going to have like a base case and a recursive call, similar to how we implement sum in the regular way in Scheme. But in this case, once we reach the base case, we want to return that number that we've accumulated, that's 6, that variable so far. And so our if condition is if the list is null, so same as before, but this time we're going to return so far. So rather than returning 0 and like backtracking and accumulating stuff backwards, we're going to accumulate stuff along the way. So we're going to accumulate that 1, 2, 3, rather than going backwards, and then we're going to return so far, which should be 6. And then otherwise, what do we want to do? Well, we want to make a recursive call to the helper function. And so same with like the sum function. And so helper, and we want to remove that first element. And then what do we want to do with so far? We want to add that first element. So in this case, we would add maybe, let's say the list was 1, 2, 3. We would add that one to the so far variable. So like accumulating that one. And then helper on the cdecooter of the list, so the rest of the list is going to handle adding the rest of those elements into so far. And so we're going to add the car of the list. And so that would be that one, that first value. And we're going to add it to so far. So accumulating it and like merging it in. And yeah, so that's going to be our helper function. And what do we have to do after? We need to make a call to helper inside of the sum function to actually like return some value. Because if we define the helper function, but we don't call it, we're not going to get the sum out of it. So turns out we do have to call it from the outside function. And so here we're going to make a call to helper, and what are the two parameters that we want to pass in? Well, first is going to be list. And so list is the same original list that we had. So if it had sum of 1, 2, 3, we will be passing in the list 1, 2, 3. And then so far is our starting value of what we want to accumulate on top of. And so in general cases, if we're dealing with like lists, so the result is like what we return is a list. It's usually nil, which is an empty list. But in the case of the sum function, we want to be adding in numbers together. And we know that for sum, we want to start by adding 0 to it. Start with the number 0 and then add the elements on top of that number. And so we're going to make a call to helper, list, and 0. And then this should be it. But yeah, if you have any questions, feel free to email me. And yeah, hope you have a great day. See ya.